Okay, cool. Thank you very much, JJ, for the nice introduction. So if I look across the room, I think most of you already know me, but I'm Kevin. I work as a solution architect for Neo4j. Been with the company since more than 4 years now, actually. And I have seen a lot of different verticals, like talking about pharma, finance, manufacturing, automotive, and a lot of use cases, or of course, in that area as well. And I want to start this keynote because I think a keynote is always a little bit about motivation, also the setting for the day and the mingling and the relationship building between you. I want to start this with a summary of the top AI graph use cases that we currently see in manufacturing and automotive industry. And actually, a couple of weeks ago, I was also here in Munich, and I was attending another conference about manufacturing as well. And actually, Alexander, you were there with me, right, from Infineon. And it was a quite interesting conference for me because a year ago, I was there as well. And what changed in this year is this year, everybody was talking about knowledge graphs. Everybody was talking about context and context engineering. And that was a really interesting switch just 1 year ago, right? And that's what we see. And the cool thing is, at the end of the conference, all of the participants and the speakers, they shared their content. And this content, actually the top categories of use cases that we see in a few seconds, there's 4 categories that we currently see, is basically a summary of this content that I've got from these conferences. Yeah? Plus our own experience, of course. I want to start with this one. So the first one directly shoots on the shop floor. It's also one of the most complex, to be honest, to achieve. But that one is interesting. So a lot of those companies in the area of manufacturing and automotive, they want to do the following. They want to make the whole shop floor intelligent. Talking about multiple factories. Every factory has multiple machineries. They have their production pipelines, their production lines, and so on. And what they want to do is they want to have a global, so company view of all the factories, of all the machines that exist, what they are doing, and want to standardize across all of this information. And that is by itself already a challenge. Yeah? But the cool thing is there's a lot of standardized data going on there, talking about OPC UA, for example, which is a nice machine standard that we could use. Talking about other standards that we can use in terms of APIs and exposed data. And yeah, the usual setup in this scenery is you have your factory, you have your machines. Usually the machines are connected to edge devices, right, in that area, and edge devices stream their information into the cloud. And the classical use cases that you want to drive with such a setup is questions like, do we actually need to buy a machine? What is the idling, for example? What you want to solve as well is something like a synchronization of the factory. So if one machine has a stop reason for some reason, they want all of the rest of the factory know about that. And currently this is a really dislocated and disconnected piece in the factories. So it's really hard to solve, actually, but this is something that they tackle currently with knowledge graphs and with context. Yeah? And especially here, context is really hardly defined, because context, and we see this throughout the day, is data basically that you want to deliver in the right type, at the right time, and in the right structure for your agents. Yeah? And that makes this so hard because you have a lot of different heterogeneous data in this case. So this one is really interesting. And you see, this is not just a particular graph use case, it's more a category of multiple use cases that you could tackle here, right? Yeah, so that's the first one. The second one is supply chain and order optimization. The whole supply chain, the global supply chain, is really complicated. And it's also fragile. If you remember a couple of years and think about COVID, we all know what happened with our supply chain, right? It basically just went downhill. Yeah? Everybody had problems with keeping track of all the changes in this system. And that's very interesting. Of course, we have a lot of different data, and the classical use cases are multi-hop supplier reasoning. You want to understand which supplier can ship me which good, which material. But if this drops out, I want to understand what happens downstream, right? What's the impact if this supplier drops out for some reason? Or do I have similar suppliers, for example, that could help me with different materials or with the same materials, whatever. Yeah, so this is a classical use case. And for those who are familiar with the graph area, I think they will recognize. Another classic is the middle part, which is bill of materials, where you need to track your products, your subcomponents, submaterials basically, that make the whole product. Yeah? So a graph, connecting parts, subassembly, finished product, and demand forecast, etc. This is everything that you could do with bill of materials. And again, a lot of different heterogeneous data points. It's something that you want to connect with a knowledge graph to provide real context to agents. Yeah? Cross-plant idle stock visibility is something actually that we're currently working on with a prospect who's interested in doing this. So what they want to minimize is all the material that is living in their storages, storage capabilities, and they want to optimize the stock movement between their factories. It's also a really nice and interesting use case. And by the way, all the categories that I show here, you will hear with my co-speakers today, you will hear examples for every category that I show here in this case. Yeah? And this one is definitely one that we will hear about today as well. The third one, also a really interesting one, right? And I think if you think about your own company, that will resonate. It's about requirement analysis and product engineering. And we all know if you want to come up with a new product and you need to check compliance and requirements and all of that, that's quite a complex task. And this is something beautifully that you also can do with graphs. So your model would be requirements, the design element, the test case, and the verification that your requirement is actually fulfilled and something like that. And this is actually one of the first use cases that I have seen in the scope of large language models, by the way. So one of the first use cases that was actually tackled by one of our partners was exactly this one. So requirement analysis for complex products. In this case, it was in the car industry. And 1 month later, I saw the same use case in the airspace industry. So requirements analysis for new planned planes, for example. As well, a really interesting use case. Compliance mapping is falls in that category as well. I have requirements, regulatory clauses. Can I certify this, right? And what also maps in here, and the picture may already suggest something like this, is that you have in a classical company that creates products, especially complex products, you have a lot of different teams interacting with each other. You have maybe one team that is taking care of the electrical capabilities, one team that is thinking more about mechanical parts, mechanical movements, stuff like this, one designer team, and so on, right? So multiple teams interacting with each other. And all of them, they have to share data and their view, but all of their ground data is again disconnected. They all use their own tools. They all have their own data lakes and data sources that they want to interact with. And it's quite rare that anything really overlaps, right? But when the mechanical team does a change to a new product, then all the rest is impacted. All the rest needs to know what's happening. And I'm not sure, somebody of you might have also attended last week's graph talk. There was a presentation from KUKA, so the robotic industry, right, from Bremen. And he was actually talking exactly about this case. So they want to have one central view for every team that is interacting in product engineering, which is basically their source of truth. It's really interesting as well. We also have public reference about this case if you're interested. And last but not least, this one is also a really nice one that a lot of people that I interact with like to do. It's especially about conflicts. So we have a requirement, they do something, and then a year later, a new regulation comes out, a new requirement comes into the system, and then, bam, they clash. Right? So one requirement contradicts the other requirement. That's perfect case and super annoying to work against. So I think everybody of you know this as well. And the knowledge graph can, with reasoning, you can basically find those contradicting requirements in this case. Another one of the nice cases that we have seen in the past year. Yeah, and the last category that I want to touch is sales and marketing. It's a little bit detached to the classical scope of manufacturing, I would say. But nevertheless, it's extremely important, right? Because in the end, the products that you build, you also want to sell. And what we have seen, an extreme rise basically in the last year is companies, they connect their data from sales departments, talking about customer 360 data, talking about ERP information systems, Salesforce information, SAP information, and so on. Again, siloed data, they want to connect all of this to have a customer 360 view of their customers. They want to understand which customers are interested in which products, what is the install base that they already have, and so on and so forth. And the really low-hanging fruit, actually, because it's not too hard to implement, is the first case here. It's the automated tender compliance drifting. That means what they want to do is they want to have an agent, and now a new public offer arises, an RFP comes in with requirements and questions, and they want to check this automatically against the documentation of the products, against fulfilled past tenders, and so on. And that's actually really, it's not hard to do with a knowledge graph. It's a perfect example. An agent, you throw in the questions, you get out the answers, you see, can I fulfill this RFP, yes or no? And the sellers, 80% of their job is already done. Which is really nice. It's extreme time saving. The second and the third one, they go more in the direction really of the customer 360 view, right? And especially when you already know which customer has which goods, install base, and so on, and also which customer likes to attend maybe marketing events or something like this. Then product recommendation is also pretty low-hanging fruit as well, because then you find similarities between your customers. Yeah? And as soon as you find similarities between your customers, because the graph is overlapping somehow, then you can do straightforward graph recommendation with really different features and aspects, but this is as well really common graph use case as well. But again, throughout the day, you will see a couple of examples. All right, so what's the challenge, right? And I already write it here. The bottleneck is context engineering today, and not model intelligence. Yesterday, actually, during the dinner, I had one conversation about this regarding model intelligence. And the question was, hey, from Neo4j side, do you track the capabilities of the models nowadays? Right, so do you say one model is better to interact with a graph compared to another model? And actually, today, the answer is, in the beginning, yes, we did. We actually checked which model was able to interact with the knowledge graph, but today, all of the models, they have a baseline of reasoning capabilities, and all of the models have a pretty good intelligence standard, let's call it like this. What's the problem today is to get the right context in the right format at the right time to the large language model or to the agent, right? In order to make an operational decision. That is the problem today. Again, a couple of weeks ago at the manufacturing conference, there was also Siemens AG was part there, and they showed an internal research. And the research stated that in Siemens, in this case, data is of course siloed. Yeah, this is a classical problem. Sometimes it's governed. So sometimes you have well-defined data scopes, you have definitions, you have entities, that works well. But even though they are governed, that doesn't mean that the department A and department B have the same definitions in place. Right? So a customer here is something else than a customer here. That's already problematic. Yeah? So semantics and definitions are really different. The one in the middle was really interesting because they were testing different options how to deliver context to their models and to their agent scopes. And that was really interesting. So a well-tuned setup usually has a hallucination rate, in their case, of 10%. And as soon as you switch the context and you really worsen up the context and mess with it, then you see the hallucination spikes basically to, also 66%, which is tremendous. And even though the intelligence brings its own knowledge, so the large language model brings its own knowledge, and reasoning capabilities, still we see 66%. Yes. Which is quite an impact. Yeah, and last but not least, I mean, this is Siemens numbers, but this is also a picture of reality, I believe. You know? AI projects still above 40 are abundant at some point, which is quite a burden, and we still see this as true. And this is actually something that I also want to ask partners that are also today here, and I would love to mingle then with you in the breaks, if you see this also with your customers, for example. Yeah, the statement of Voith was, when the context is not clear, then the AI project will fail, most definitely, today. And yeah, the top 3 reasons why this is problematic to really work with context and make context available is silo disconnection. Can't say it enough. We have snowflakes, we have Databricks, Salesforce, Confluence, SAPs, different tools, different semantics. We have fragmentation as well, which means sometimes you have duplication, sometimes you have a weak alignment between those data tools, and so on. This is another problem. And definitely there's a treasure of unstructured data in the companies. The core data usually is structured. And it's structured for a reason, because in the beginning of the company it was really important, and that's the reason why you structure it, why you put effort in and make it as clean as possible. But then you have a huge set of unstructured treasure basically laying around, right? A lot of knowledge is in there, but it's really hard to use operationally, right? Classical top reasons. And now our statement, right, might be bold, but I think there's also a lot of evidence out there that this is also true, is when you work with a knowledge graph, when you introduce semantics and relationships between your data points, that by default makes your data AI ready. And I am certain of that, because I see a lot of use cases and customers. But here's some examples. So the problem, the usual look. Everybody of us knows how a table looks like, right? Typical relational data. If you provide this to a large language model, then he can work with it. Let's call it he. It can work with it. It can work with it, right? But the problem is, the large language model doesn't know the relationship between column A and column F. How should it know, right? It's just a table, it's data in there, nothing else. And another truth is, this table, exists everywhere. Different meaning again, different definitions. How it should look like, and that's the usual approach, is have a proper ontology or data model in place where you can read through it. And that was, by the way, one of the best practices that we always teach to beginners in the graph space, is when you can read through the model, then usually it's a good model, right? Customer bought product. You can read through it. You understand it right away, right? Or application is built on a service, something like that. The different colors here means you have different sources. Maybe blue might be Snowflake, green might be Databricks, red might be SAP, for example. So you create one overlapping graph layer and connect your entities. And that works out usually really, really well. And one point that is fair to make is we are still talking about large language models, right? Language is the core of it. And that's the reason why I want to highlight this, if you can speak through the model so drastically. Because the language will tell you the relationship between entity A and B, right? And that fits very well. That's usually set up that we nowadays see with our customers happening. So it doesn't matter if we deal with structured data, semi-structured, or a lot of unstructured information. We want to compose it into an overlapping knowledge graph. We don't mind the sources. We create tools that will help us with deduplication and entity resolution, so that we actually can link between different silos. And there will be also a talk from Siemens about this setup today, so looking forward as well. And with this knowledge graph, then in the middle, we can drive agents, we can drive our operations, but of course also our analytical part. Great. If you have questions about the graph analytical part, feel free to approach me. That's really also where my heart beats as a former data scientist in the graph area. Yeah? So if you want to nerd a little bit about graph algorithms, come to me. Yeah? Yeah, this is the classical architecture that we see. So one overlapping knowledge graph. That would be the ideal picture, but of course this is not always doable, right? Sometimes also customers like to start step by step. And with step by step, sometimes they do something like they have an ERP system, and then they do an ERP graph, right? Then they have a particular information in Snowflake, and then they make a dedicated graph out of that. But the nice thing is, with Neo4j, you can also do composite graphs, right? You can use that, and you have a layer above that can query both sides. It's also possible, and that's also sometimes what customers are striving for. Simple. Yeah, classical setup. Yeah, the combination is, like my statement was, AI ready by graph design is actually based on this here. So this knowledge graph side, where we have knowledge, facts, context, and the GenAI side that beautifully works with language, with statistics, and also with the reasoning capabilities to reason about your data. This combination, I believe, is one of the most strongest setups that we see today in business at all. We have seen different vendors putting up their setup, talking about semantics and handling siloed data and all of that. But you see that even a vendor like Databricks or Snowflake, now they are all also talking about knowledge graphs, right? They never talked about knowledge graphs in the past, but now it's the time. And they see the power of the semantics layer, right? And this combination is the key. Yeah. To just summarize, so the knowledge graph will help you with contextual information. Relationships as primary data structure is the body. You have the flexibility. That means you can start really small, step by step. You can start with an initial graph model. If you want to pull in more information, a new data source, no problem. You can expand your data model, right? Make it just bigger and grow it over time. It's easy. You can evolve. And last but not least, you can introduce your standards. So you can introduce your meaning, your semantics to it as well. So these three aspects will help you with the whole setup of a project delivery in the GenAI space. And if you want evidence about this, then I can also tell you about this one. Because a couple of weeks ago, there was a new study, a white paper published on our site. It is coming from the IDC, so an independent consortium that is checking our customers. So those people talk to our customers and they ask questions about KPIs, business use cases, setups, data sizes, users, etc., right? The cool thing is the IDC is an independent consortium. That means when the customers tell them, well, doesn't work, product sucks, it's not fun to work with it, then they would publish it anyway, right? But that's the cool thing. And of course, it's worth to have a read. So I added you the link here. Have a look. We have clear KPIs and business ROI statements on this setup. And that's worth to have a look on and also share, of course, with the people that are still a little bit doubtful regarding knowledge graphs. Is it worth or not to put in? Interesting resource. Last but not least, and I hope I'm still in time, but please tell me. One really interesting case that was also happening in the manufacturing conference where I was attending was the case from Voith. Voith is a company that is building mechanical pumps, everything related to water, electricity generation. And they had a quite interesting setup because they built it themselves, and I was really blown away by their engineering setup there. They built basically a virtual graph layer. And what they built is they built something that they call the base layer. I would call it the base graphs, you could say, and the virtual layers. And the base graphs is what I told you before, like dedicated small use case graphs, but packed as a data product. So one use case was Customer 360. Customer 360 was involving ERP data, a bit of Snowflake, a bit of Databricks. All in one graph, packed as a data product. Another graph now is, for example, the document graph about products. A lot of unstructured information about documentation, product data, meta information, and so on, packed as a data product. This is the base layer. And now the virtual layer is, for everyone, they have access to those data products, and now they can basically compose their graph that they would need for their use case. I have a use case that needs product information, customer information. Let's take both of them, and let's create a new virtual graph that uses both of them. That's a super nice setup, to be honest. You can do it step by step. You grow bottom up. It's a cool thing. And then I thought, well, that was roughly 3 weeks ago. A couple of days later, our product came around the corner and was introducing Neo4j virtual graphs. And I thought, poor Void. Now they build everything themselves, and then a couple of days later, basically our product introduces the same concept. Yeah. It's slightly different though, but still it's talking about virtual graphs, and I'm not sure if you heard about this like a few weeks ago. Okay, a couple of you say no. This one is a new product feature, which is quite impactful, and I already see this with my customers. This is a product feature where you can leave the data where it is, and that's usually in the data lakes, right? So talking Snowflake Databricks, for example. And you can create a virtual graph layer on top of it. Yeah, so you do a mapping of your tables, warehouse tables, for example, into the graph scope, into the graph world, and then you can work with that. Yeah? That means you have this mapping in place. The data sources, for starters, will be Snowflake and Databricks. Yeah? So this will be already supported for the AAP. You define a graph model, that is the mapping. And you can also define the user questions, basically, that you would have against the graph. Usually those two, they come hand in hand, right? So if you have the questions, that will define your model. That's usually the best practice, how we phrase it. When you define the mapping, then you can work out of the box with all the tools that we support on top of Neo4j. Talking about Bloom, Query, GDS, Graph Data Science, Aura Graph Data, Aura Service, Aura Sessions, and also agents, MCP server. Everything is supported by default with this setup. And what happens is, for example, when you execute a Cypher query, then the Cypher query gets translated and pushed down to the source systems and will be executed as an SQL query, for example. And this is a real trade-off. The trade-off is you save all the struggle with ETL, which is usually a bigger part in the project. You can easily test from table to graph, but, and here's the trade-off, it's still a pushdown of Cypher down to SQL. And just imagine, if you have a Cypher query that hops 20 hops, 50 hops, 100 hops, that would translate in SQL into 20 joins, 50 joins, 100 joins. That might be not optimal, right? So it depends a little bit on the use cases that you want to execute, but it's definitely a door opener and a Kickstarter for all the potential graph use cases that you might have in your mind. Because you can say the data leaves never the source system, Snowflake Databricks. You can test your use case, and if you see value in them, if you see it works well with context and with the agents, then you can make the decision to either proceed with the virtual graph or to do a native graph setup. Yeah? That's a usual architecture that we would see. Yeah? So we have Neo4j. Doesn't matter if it's hosted here in Aura, but it can connect basically to Snowflake and Databricks. And you can run either machine learning part with using graph algorithms, for example, on the virtual graph, or you can use the GenAI domain with agents, with MCP, with tools, everything that you can think about it, that is out of the box supported with Neo4j on top. And that's a really nice setup as well. We introduced this to our customers and to our prospects, and everybody was shipped on day one. Because all the governance usually happens on the data lake. Right? It's a nice setup. I'm really looking forward to the next year using this for all the use cases. If you're interested, I added this to the slides. So you can also check out the EAP. Just log in, you can check it. You can try it yourself. There's already material out there about how to set up. There are videos about this available, and also some tutorials as well. All right. Just wait a second for the pictures.
Okay,
Then just slide.
There we go. Summary. It's just one slider, actually. So from my perspective, with all the experience that we've got in the last year, in this whole scope of large language models, agents, context engineering, we see these three statements. Yeah? So the option is start connecting your siloed data. It's easier to say as to be done, of course, and add semantical relationships. Second one is enhance retrieval AI systems with GraphRec. Of course, we need good context at the right time, right amount. That's, of course, a given. And be flexible with your data architecture. Yeah? Especially, and that's a nice thing again about a graph, you can be flexible. You start with 2 data sets, add a third one, add a fourth one. Doesn't matter. You can expand the scope, you can experiment, and as soon as you hit production readiness, then you fix it in place with a schema and with constraints. That's the setup that we usually do, right? Yeah, and the clear statement is this part. It's just one sentence, but I believe it's really, really true. And it is, organizations are drowning in data. Data is available left and right, contextual, structured, unstructured. But AI is still starving for context, and that's the point. All right, with that, I want to close, and I want to empathize you, everyone. Use the time. My work is mostly about building relationships, and I take this literally, right? So take the time, mingle, talk to your peers, and let's have a good time. Thank you, everyone.